So, welcome again. This is the lecture 5 of the air pollution SWAYAM course that we are covering actually. So, in this lecture we will discuss air pollution and its impact. Just to recall, in the last lectures we talked about particulate air pollution, atmospheric aerosols, their importance little bit, and sources and composition. We could not cover this one, so we will cover in the next lecture. And size distribution of and properties of aerosols we could not cover also, so we will cover again here. Then we will cover ozone, air pollution and plants, and their impact on plants. In this lecture we will cover mostly on the factors that are affecting air pollution and consequences of air pollution, with the another few things like size distribution and properties of atmospheric aerosols that were left in the previous lecture. Okay. So, as I said that aerosol particles, their size is actually say generally 1 nanometer say to say 100 micrometer, but if you see in the y axis and the x axis rather, the size, if you see very hardly particles more than 10 micrometer. Okay, this is very hardly any particles you see, very small number of particles, and this is minded, this is actually number size distribution concentration, number size distribution. So, number size distribution means, so this is actually size distribution. So, size, if you see here, this is x axis is the diameter, and you see that 0.01, 0.1 and then 1 and then 10. So, order of tens magnitude is there actually. So, this is not a linear scale. Okay, and in the y axis size, y axis, if you see, this is number distribution, the particles, number of particles of that particular size in 1 cubic centimeter of the air. If you take 1 cubic centimeter of volume, how many particles are there? So, as you know, and it's as it's very clear, the number of ultrafine particles, this is called ultrafine. If the particle is less than 0.1 micrometer, it is called ultrafine particles. They are actually much higher. And if you see the size distribution like this, it goes like this. It's less than 0.1, and then maximum will be around somewhere around 0.01 or 1 to 5 nanometer or so. So, these are the ultrafine particles are in the nucleation mode particles. So, these are two things that are called actually, usually generally they are called nucleation particles, and if you include particles up to 0.1, so this is actually called ultrafine. So, up to 0.1 this is called ultrafine. Okay, and then 0.01, if you see this graph which is extending here somehow, and if you just back plot this one like this, this is actually called accumulation mode particles. So, you have nucleation and then you have accumulation. So, part of accumulation mode particles and all of nucleation mode particles, they are together defined as ultrafine particles. And then you have up to from 0.1 to 1 micrometer or 2.5 micrometer, they are actually generally will be heavy like PM 2.5. So, size arrow is here, actually limit is here, and then from 2.5 to 10 you hardly see these are coarse mode particles and you hardly see any particles. There are number concentration is very less compared to the ultrafine or nucleation mode particles or accumulation mode particles. So, this is very important. So, the way you should remember this one, NAC, the size distribution, number particle size distribution, if you remember, is actually NAC. N means nucleation, A means accumulation, and C means coarse. So, NAC, you can just remember the size, these things. Now, if you just see this one, this was actually based on the size. Now, what will happen if you look at the mass or volume size distribution? When you see the mass size distribution or volume size distribution, it shows a very good bimodal distribution, and that the mode actually, if you see, this one mode is here somewhere around say 500 nanometer or so, and then other mode is somewhere around 10. And some people based on this one actually, so you should have particles, maximum particles with mass that is actually somewhere around 0.5, and then if you see here how much they are going here, you will be here like here, this one top one. So, this becomes very important, but unlike this one, that ultrafine particles were dominated in the number concentration. If you see the mass contribution, size distribution or volume size distribution, ultrafine particles, they will be contributing very less. So, the contribution of ultrafine particulate matter will be very less in the volume or mass size distribution, they will be majorly because of the accumulation mode particles, okay, and then the other one will be the coarse mode. Now, this is very important here to remember that although coarse mode particles concentration is very low, you see here in the other slides the concentration is very low, but they are contributing very high, or they are contributing significantly to the mass or volume size distribution, because their surface area is very high, and then because of the even if they are very smaller, say if you can imagine that 1 micrometer particles and 10 micrometer particles. So, if you have 1 micrometer particles and 10 micrometer, there will be almost like 1000 of particles. So, 10 micrometer divided by 1 micrometer, and since it is varying with the diameter will be d cube r cube. So, concentration will be varying. So, you have 1000 particles. So, the mass of 110 micrometer particles will be equivalent to the same particles with 1 micrometer size, but 1000 particles. So, this is very important, and that is why you see that coarse mode particles are contributing here. So, if you talk about the properties, why do we have actually these two size distributions are very important? Because when we study chemical properties or chemical composition, then mass and composition, they are actually very important, and they will be mostly governed by the mass size distribution. Also the little bit of the reactivity, acidity or alkalinity, so which is actually dependent on the composition, and then water uptake or solubility. These are the things that will be governed, these chemical properties will be governed by the mass loading, and then of course volume size distribution and mass size distribution becomes very important, and chemical composition of aerosols will be governed by the mass size distribution. And if you see here, this is also related to the particle formation and post particle formation. So, when the particle formation is happening, there will be actually some new particles will be formed, but whether they will be stable or not, so that depends on the equilibrium, or lots of thermodynamical properties will be there. This lecture is basic, so I am not going in that details. So, post formation processes are very important to decide whether the particles will be stable or it will be still a reactive one. Okay. There are various atmospheric processes that are happening that are important, and that will also depends on the chemical composition. Organic and inorganic fractions that are there, actually they are also depending, their fraction depends on the chemical properties and chemical composition. So, one need to study their actually size distribution. Which size distribution? Volume or mass size distribution. Okay. And if you want more details, you should study actually PM 2.5 and PM 10. So, PM 2.5 particles separately, the composition of PM 2.5 particles and composition of PM 10 particles, that will be very different. So, and if you talk about fine and coarse mode less than 2.5, this should be 2.5, 2 should be 2.5, and then coarse mode 2.5 to, they will be very different actually. Then apart from that one, when we talk about the physical properties, like hygroscopicity comes in both actually. So, it is actually somewhere between it is also treated as a chemical property, and sometimes it is mostly it is physical, but sometimes because of the uptake and reactivity and then uptake coefficient, this is also defined in the chemical terms. Then physical property is highly dependent on the size and number distribution, because surface area becomes very important here. If you want to again reactivity, heterogeneous reactivity, then surface area becomes very important, that you have to keep in mind. Then particle shape is actually very again very important. Coagulation and condensation processes that is happening in the atmosphere. Then optical properties of aerosols, these will be governed by the number size distribution. So, number size distribution or mass size, number size distribution, mass will not be here. So, there is just a mistake of mass in here. So, fine mode aerosols are dominant in the number less than 2.5 as I said, and peak around 0.5 micron in the last slide we showed, but towards mass its contribution is very less. So, only 5% they contribute, less than 2.5 micron particles, they contribute only less than 5% for the mass, but they are dominating in the number size distribution. And then fine mode aerosols are very important to study the optical properties. The next one is actually like what are the factors that affect air pollution. This is very important, and this is generally asked in lots of UPSC exams, interviews, that what are the factors. So, of course, what are the factors? First thing is emission, source itself. So, if the source is varying, source or emission is there. For example, now we have in this season we have agriculture based burning. So, that is another source that is actually added up. So, you have a emission, more emissions. Okay, emission could be traffic, industrial, domestic, or kind of vehicular emission, and then cooking in the domestic, for example, cooking purposes, heating purposes, and then you have a kind of agricultural based burning and other things. Geography is very important. If you we will see that when just give me a second, I will come to the next slide, it is there actually. Then weather condition, weather, rain, winds and humidity. This is also very important to decide whether the air pollution and how much air pollution will be there. Aerosols exhibit a seasonal variation. So, seasonal different seasons the composition will be different, and then air pollution levels will be different. Not only that, even we have a diurnal variability. So, within 24 hours aerosol concentration and gaseous air pollution concentration, both particulate and gaseous, they keep on changing. Then population density, because population density, if more number of people are living, you need more of energy, you need more food, you need more transportation, you need more electricity. So, there the pollution level will be higher. So, for example, in the urban areas you have high air pollution compared to the rural areas. Then you talk about the indoor and outdoor air pollution. Whether you are talking about the indoor, I mostly talked about the outdoor pollution, I did not talk about the indoor air pollution, but this is also coming very important. Okay. So, if I just ask you that what are the controlling factors of pollution and why Indo-Gangetic plain is so polluted. So, if you see this one, Indo-Gangetic plain is situated in such a way that it contains the emission sources are also very high. So, you have primary, natural and anthropogenic, both the sources are there, and in addition top of that you have a secondary organic aerosol formation. Okay. The meteorology, during the winter seasons you have actually a shallower boundary layer height. Boundary layer height is actually kind of imaginary layer that is actually distinguished and that keeps entrapping all the aerosols below that layer. In addition, we have a low wind speed compared to those in the summer, because in the summer we have high wind speed. In the winter, when it comes to the winter, the wind speed reduces, so you have a less dispersion of aerosols. The temperature and relative humidity, usually we have a lower temperature and high relative humidity during the winter season. So, that also leads to the air pollution, that also decides the level of air pollution, and then lack of rainfall throughout the year. This is very important. Unlike other countries where we have actually annual rainfall, India we receive only rainfall during a particular season. During monsoon we receive the rainfall. So, what means that during 4 to 5 months we have rainfall, other seasons we do not have rainfall. So, rainfall is actually one of the very wet scavenging. So, wet scavenging is a very important process to remove all the aerosols. So, if it is not there throughout the year, aerosols will not be removed, they will be removed only the dry deposition, and as I said that dry deposition is important for bigger particles, but for the smaller particles dry deposition is not actually important at all. So, these aerosol particles will be keep on hanging in the atmosphere, they will be transported from one place to another place. So, this is another big issue, transboundary or pollution from the neighboring states, you can have that kind of pollution. And then geography, if you see topography and the Himalayas. So, if you see here what is happening, here you have a Himalayas and this is the cold front that is coming from the Himalayas, and you have pollution that is coming from these areas, you have biomass burning here, and then wind speed is like this. So, when this comes here, it is pushing in the Indo-Gangetic plain. So, this is pushing, this wind is coming. So, it will be like circulating, it keeps on here, and this ultimately will go to the Bay of Bengal. Suppose this Himalayan barrier was not there, what would have happened? This aerosol which was channelized during the Indo-Gangetic plain along the Gangetic plain, this could have been dispersed this way, but it is not happening because you have a high barrier, actually barrier of Himalaya. So, if you just remember that if you have a room and if the wind speed carrying the pollution is coming and that the wall is there and then this is stuck with the wall, it will not move up further. Of course, there are actually studies that suggest that air pollution from this region can be advected. There is a advection mechanism from there, but that is very less actually. So, this because of this region, these are they only allow the transport of aerosols along the Gangetic plain to the Bay of Bengal. Okay, and because of the low wind speed, this they restrict the advection or transport of aerosols towards the north. So, in the Himalayas you do not see much of the aerosols because of this region. So, this is another very important features. Okay, and then on top of that you have additional aerosols from the upwind sides. So, if you are, for example, if you are in Varanasi, you are getting aerosols all the way from the upwind sides that is actually transported. Okay, one very important things, and I think it is very important, lots of short notes and short questions are asked on this one. What are the consequences of aerosols, air pollution? So, there are many actually: poor air quality and visibility, photochemical smog, acid rain, climate change and their role in the aerosol and precipitation. Okay. This is the picture taken during the clean day. You can see the peaks here, mountains and other things, but this is the moderately polluted days. Can you see this one? Actually not. So, not much of the things are there. This is what is happening when you have high air pollution, the scattering becomes too much. So, you can't see this one again. So, the particles concentration affect the visibility. You have very nice clear view of this snow and ice, you can see here, beautiful picture. But when the aerosol concentration becomes little higher, say 12 microgram per cubic meter, you can see the hazy things. You can't say that it is actually like a snow covered or not actually. You cannot distinguish this one. When the concentration becomes further up, 22 microgram per cubic meter, it's almost like you have to very carefully look it, then only you can see that okay, something is there on behind. But when this is actually about say 65 microgram per cubic meter, you can't see at all. Nothing you can see. Now, this is the same location, picture taken from the same places, but different concentration levels. This is very important. I thought of covering the concept of visibility with the mathematical calculation, but I am not, because I need to write this one and I am not doing this one. So, maybe I will find out some other way to do this one. Okay. Then the other example is actually photochemical smog or brown smog, brown air. Okay. So, smog, what is smog? There is a different actually. So, smog is actually smoke plus fog. So, you have lots of unburnt hydrocarbons and aerosols that are there, and you have a fog. Fog means high humidity. So, this like you have in Delhi, lots of air pollution with high relative humidity kind of things, you can have fog. But when you say photochemical fog, photo means photon, you need solar radiation, and this actually layer is there. Here you do not have much of the particulate air pollution, here you have mostly the reactive series of reaction that is happening with the reactive species, like volatile organic compounds are there. So, this is mainly driven by the primary pollutants and normal atmospheric compounds. Photochemical smog, and it happens when you have a hot, sunny and windless days in the urban areas. So, mostly it happens in the urban areas because of the vehicular emission, you are putting lots of particulate matter, carbonaceous aerosols as well as volatile organic compounds in the atmosphere, and these volatile organic compounds and NOx, they are actually getting converted to the secondary particulate matter, and this secondary particulate matter to happen, you need solar radiation, and the solar radiation is there. So, you need hot and sunny days. Okay. So, for example, in the morning traffic exhaust releases the pollutants. Okay. So, this is what is happening, and it can irritate your eyes, nose and throats. So, if you just happen to see that if you are traveling and you are walking or you are using a scooty or bicycle, and if some vehicle is not in good condition, it emits lots of smoke. Smoke is so intense that it produces lots of carbon monoxide that even you can you may actually kind of feel very anxious. You may not be feeling very good and बेहोश हो सकते हैं आप वहाँ पर जाकर के, right? Vehicular kind of things. Okay. And smog. So, smog, this is very important question that is asked, that what is the difference between smog, sulphurous and photochemical smog. Sulphurous smog that happened actually in the London 1952. Okay. This was mostly driven by smog plus fog, and this was driven because of the SO2 that was coming from the coal combustion. So, London smog was caused by lots of sulfur dioxide that were released from the coal combustion, okay, industrial processes that happened there, lots of SO2 came into the atmosphere. Now, I talked about that if the SO2 is keep on accumulating in the atmosphere, what will happen? This concentration keeps on rising, and this is where it becomes very important that photochemical reactions, they can turn into they can oxidize sulfur dioxide through series of reactions to sulfuric acid. And this sulfuric acid is very strong acid, and once the people inhale, when they are inhaling, so you are inhaling that one, so you can inhale this sulfuric acid droplets, and when they inhale, your body becomes very acidic, lots of things can change, and that is what happened during the London smog. This was characterized by, again, as an inversion, cool weather and coal burning. So, this was mostly caused by the coal burning condition. But in the Los Angeles, for example, this is actually an example of photochemical smog. So, you have a very high intense UV radiation from the sun, hydrocarbons and NOx are produced because of the vehicular emission and industrial process. They are characterized by hot, dry and sunny weather conditions. They reduce the visibility and high oxidant level. So, again the oxidant level is also very high in this period, and suppose imagine a situation that those oxidant levels were not there, these hydrocarbon and NOx would have been there in the atmosphere for very prolonged time, and if they are in the very prolonged time, they can further cause the problem. So, this is actually kind of reaction that what happens during the industrial smog and photochemical smog. So, industrial smog, you actually coal and oil, you produce lots of actually sulfur, the coal contains lots of sulfur, okay, and then in the oxygen when they are burned, they produce lots of SO2, and this actually oxygen, again if they combine sulfur trioxide they can form, and through the water uptake they can form this sulfuric acid, and then of course if ammonia is there, then it can neutralize this one. If the ammonia is not there, then this sulfuric acid there will be there in the atmosphere, and this can be inhaled by the people living there, so it will be very dangerous for them. On the other hand, you have a photochemical smog. In the photochemical smog, you have basically nitrogen, lots of NOx is coming from there, and then oxygen, nitrogen, that is there actually combustion process, lots of NOx is generated, oxygen is there, you convert it is actually nitric oxide, so NO, and this NO can be further oxidized to nitrate or HNO3. So, this is very important, a series of reactions. I am sorry I cannot read from here. This is actually very series of reactions that are happening here, that can you see this one. This is the question that is asked, that Great London smog that happens in 1952. I talk about this smog was intensified, fog that was intensified with the smog, and if you see how this was here, actually this is the depth is given in the number, and then dates in the December of 1952. So, it peaked during the 5 to 11 December 1992, this peaked actually, and people recorded this one. So, this actually is the number of deaths that happens, you can see this one, and then during that period they measured the sulfur dioxide concentration and smoke concentration. So, you see that there is a peak that coincides with the number of deaths, peak of sulfur dioxide and smoke, they coincide with the deaths, and this was the very clear signal and indication that led to the conclusion that London smog was caused by the high SO2 concentration and then intense high. So, this is actually very important, and then almost like 8,000 people died actually, okay, and this leads to the formation of Clean Air Acts in 1956 and 1968 in the city of London. So, this is what is actually much needed now in India as well. Actually, we are putting lots of pollutants in the atmosphere, but the problem with India is that India, being a developing country, it has to actually keep its growth as well actually, and it cannot stop its growth actually, industrial and then all the growth or agriculture productivity, nothing they can stop, but there has to be some way down that we have to reduce this one. There has to be a sustainable approach that we have to adopt. We cannot keep on increasing the concentration. The other effect is actually acid deposition. So, acid deposition we usually means when the pH level of the water or the rain, especially rain. When we say acid deposition, we generally talk about the rain. So, if the pH level of the rainwater becomes less than 5.5, it is called actually acid deposition. So, now you imagine in the atmosphere, what is the pH of the water, pure water? It is actually 7, neutral, nothing is going to happen. But what is happening in the atmosphere? We are putting lots of carbon dioxide, we are putting lots of sulfur dioxide, we are putting lots of NOx in the atmosphere. All these are actually CO2 is oxidized and this is converted to carbonic acid, okay, H2CO3, and it gives one proton there, H plus ion it releases from there. You have then sulfur dioxide, this can be converted to the sulfuric acid. Mind is this sulfuric acid and the nitric acid that are produced in the atmosphere, they are mostly neutralized by the either by the ammonia or what you call actually dust aerosols. Dust is a very crustal aerosols, this is very actually basic in nature. So, you have acid on one hand, sulfuric acid and nitric acid, you have what you call crustal dust on the other hand, calcium carbonate mostly, calcium magnesium carbonates. So, they will neutralize this acid, and this is one of the reason in India we do not have much of the acid rain. So, acid rain is not very common in India, it happens in mostly in the developing countries where you do not have dust actually, or less dust, okay. You have dust, but you have less dust. So, you do not have a neutralizing agent there. So, when you do not have a neutralizing agent, those acids will be there in the atmosphere, and when the rain happens, they can be dissolved in the water and they can form this kind of acid rain. So, this sources of the acid rain, as I said that because they are produced from the fossil fuel that can release the sulfur dioxide and nitrous oxide, and these compounds can in a series of reactions can react and produce the sulfuric and nitric acid, which can be converted into the rain. So, if you see here sulfuric and nitric acid that is produced, and you have cloud here and then precipitation happens. So, they can be actually taken away with this one. Here you have industrial process which is producing lots of SO2 and NO2. So, typically carbon dioxide is there which is actually one of the cause for the acid rain. One of the cause for lowering down the acidity or the pH level of the rainwater, but these are two very important strong acids that are there in the atmosphere. So, what are the effects of acid deposition? If you have a more acid deposition, nutrients can be leached out from the topsoil, this is very important. Okay. So, nutrients can be leached out from the topsoil. Several metals, aluminum, zinc, they can be converted into their soluble forms and they can pollute the water. This is again very important. So, they can not only leach the topsoil and in the topsoil, and because in the soil you have lots of metals, and then major elements. So, these major elements can be actually leached out and they can form soluble forms, and they can be once they are in the soluble, they will be going to water and then they can pollute the water. Means whether it is groundwater or river water or lake water, they can damage agriculture crops. This is very important. And if you live in a village, in earlier days people talk about that because of the acidic rain, the potato crops, especially these potato crops, the leaves of the potato crops can be damaged, and then you do not get much of the crop this potato productivity. This affects surface water and kills fish, as I said that one. So, if it is more acid rain, then it will reduce the pH. So, in the low pH the fish cannot survive, they can die. Widespread tree mortality. So, if again if the acid is more, then it goes in the roots and then tree can be actually they cannot survive. Then this is very important, erodes stone buildings, corrodes cars, erases writings on the tombstones. So, this is one of the things that actually we talked about, that monuments can be actually, because monuments they are mostly produced either they are stones, and stones are nothing but actually they contain lots of calcium and carbonate. So, they are basic in nature, and once you have acid they can be actually corroded. Okay. Then last, drivers of climate on the longer time scale. So, This is actually a different topics altogether, climate change, but just remember that the climate change can be caused by two factors. One is internal and external. Internal is like plate tectonics, volcanic eruption, ocean circulation, changes in the water vapors and greenhouse gases, or change in the ice cover and vegetation. These are the internal. If you remember in the very first lectures, I gave importance of the albedo. So change in the ice cover and vegetation, they can change the albedo, so that can be there. But then these are the plate tectonics, volcanic eruption, ocean circulation, and these are the three very important things. So these are not out of the scope of this topic, so we will not discuss that one. And then externally they can actually affected by the sun earth geometry, okay, and then sun's intrinsic variability, like solar flares. So sun is actually giving, and we have a 11-year solar cycle. When the I talked about that solar constant, that was actually about 1370 to 1372 watts per meter square, which is supposed to be constant. It's not, but it varies a little bit, about 0.1%. And then we have a 11-year solar cycle. So after 11 years, the peak, there is a peak actually, higher solar radiation will be there in the atmosphere. So those things, and then if you just couple with the albedo, you can see these aerosols, because albedo will be mostly affected by aerosols. Once the aerosols are deposited on the ice or glaciers, they will reduce the albedo. So that is one thing. And then if you remove the vegetation, or if you remove cut more trees and don't plant that one, then albedo will reduce that one. So that is again will contribute to the albedo. So this is one thing that is there actually. And change in the water vapor and other greenhouse gases, I talked about the importance of methane there, CO2 and methane. And here is actually aerosols. So they will also lead to the change in the climate change on a longer scale. Not only that, air pollution and climate change, how they are going to affect. If you increase the NOx level, what will happen? There will be a decreased lifetime of CH4 and HFCs, because the OH radicals, via the OH radicals, and once they are produced, so you will reduce the radiative forcing, means you will cooling, it will be kind of cooling. If you increase the ozone concentration, means you are going to increase, ozone is actually global warming species, so it will increase the radiative forcing. So it will lead to increase in the temperature of the atmosphere. Air pollution, they will increase more nitrogen deposition. I talked about the ocean deposition over the ocean. So more nitrogen deposition, this means nitrogen is now available for the phytoplanktons, and they can grow there, they can use them as a food. That is called ocean fertilization. So the fertilization process can happen, and then what will happen during this process, carbon dioxide from the atmosphere can be actually taken up by the ocean. Ocean actually is one of the largest sink for carbon dioxide. So once you have more CO2 uptake, you will the radiative forcing or the kind of this will reduce. So you will have less radiation. This means it will be having again the cooling. So net effects is not very clear, and because of these things, but very significant impact on the radiative forcing is expected. So it's a kind of multi-pollutant, multi-effect problem extends towards the radiative forcing. So if I just give one example, acidification. If you increase the SO2, acidification will increase. If you increase NOx, NH3, acidification will increase. Eutrophication, this is another topic. NOx and ammonia. Ground level ozone, if you increase the NOx, ground level ozone will increase, and VOCs of course. Then health effects via primary and secondary aerosols. Here they will mostly produce the primary, they will all contribute to the positive, towards the positive one. And if you see the radiative forcing, if you increase CH4 and CO2 and other greenhouse gases, you are going to heat up the atmosphere. So you actually are going to have a more global warming. And if you are adding the aerosols, are via the OH radical. So both are the things actually. Aerosols will produce kind of if you have more of black carbon, this will produce warming, but if you have more of scattering aerosols, they will increase the cooling. So thank you. In this lecture we talked 3-4 effects of air pollution that are very important for that are very important to be studied in the future actually. Acid deposition is one thing, but luckily we don't have acid deposition because we have lots of neutralizing agents, especially ammonia we have, and then we have lots of crustal aerosols. So this keeps on, so that is one good news. But at the same time, if we keep on increasing SO2 and NOx concentration, even they are actually the buffering, they act as a buffer agent, they reduce the pH, but still the chances are there. In some regions the pH can be lower, okay. And then photochemical smog, smoke and smog, that will be of course there. There is another very important term that is called Asian brown cloud, or after a long repetition, people after long discussion, it was termed as an atmospheric brown cloud. So in the atmospheric brown clouds you have aerosols that are produced by photochemical activities. So that is another very important thing that we talked about. We talked about the London smog and then how they differ from the normal smog days. So these are the things that are very important for us and to keep in mind and when we are studying this one. So thank you very much again. We hope to see you in next lecture. Thank you.